Hey everyone, welcome to PrepFusion. So this is the lecture 11 of state space. So in this lecture we'll just solve questions, right? So yeah, mainly whatever we have learned till now, right? Whatever we have learned till now, we'll solve questions. So in gate also, right? You will just not do like this. You studied one topic, then you solve one question. Then you studied one topic, then you solve one question, and you forgot the previous questions, right? Previous topics. That's not how it works. So basically, right? You have to solve all of the different topics at once, right? So that's how we do. You in preparation, what you do is you study one topic, then solve questions, then you go to the previous year questions and solve all the questions of all those topics directly. Okay, so that's how you should do. So in the previous lecture, right, I gave you one homework of this question, right? So what was the question? So we have been given a state space representation for the circuit, right? For the circuit we have been given state space representation. We have to find the value of x, y, z, which are here, okay, and also the R1, L1, L2 and C. Also draw the state diagram for the following circuit, right? So yeah, let's start. Let me first copy the circuit. Okay, directly I will derive the state space representation, and from there we'll see if our answer is like matching with this A matrix or not. Okay, so obviously it will not match because R1 and L1 are different, but yeah, like we'll have to match the values of each element, right, of the A matrix. So first, right, like the hint you already got that this has 3 state variables. Okay, this IL1, IL2 and VC, right? So the first hint is already like given away to you. So what is the second like thing you keep in mind? So second thing is we have to write in circuit the different like currents and voltages, right? So this I1, right, I1 is IL1 only. Okay, have I written it I1? Okay, I have written it like I1 only. So this I1 is IL1 only. Okay, no worries. Now VC, right, VC is this one only. Okay, all these are marked already in this circuit. So like I won't be able to write static equation. So one thing I'll be able to write here is this VO, right? This VO I can write here is like VOT equals to I2 of t into R2, right? I2 of t into R2. Okay, so V of t I can write like that, I2 of t and like another state variable into R2. Okay, now for capacitor, right, I gave you like I told you in the previous lecture that we have to take care of the like right in terms of current, right? So what is this IC equals to? IC, so I have IC here. What is this IC equals to? IC equals to this I1 minus I2, right? So I1 minus I2. So like again, right, simply what I can do is like this is C dVc by dt. So this becomes C Vc dot equals to I1 minus I2. So it is understandable, right? The bracket we have t. So okay, that is understandable by you. So Vc dot equals to I1 by C minus I2 by C. Okay, this is understandable. Okay, so this is what the like voltage equation is now, right? Now what I can do for the inductor, right? What I can do for the inductor? So always for an inductor, right, we have to keep in mind of the voltage. So what I can do is simply write a KVL here, right? Write a KVL here. Okay, so if I write a KVL over here, what I will get? So this was KCL. Now the KVL, right? So KVL is simply minus VI, this is plus I1 R1, then plus VL1, so this one, right, this inductor. So let me mark the voltages. So this, right, this is plus minus VL1, this is plus minus VL2. Why this is plus minus? The current is going like this, right? So positive terminal, current is going like this, so positive terminal, current is going like this, so positive terminal. Okay, so I have already told you the notation in previous video, right? So yeah, this is VL1. Now right, this is VL1. Now right, okay, what is this? This is VC only. Okay, so this is plus, okay, change the thickness, plus VC equals to 0, plus VC equals to 0. So what is I1 equals to? So this, right? So what is VL equals to? VL equals to VL1 equals to L di1 L1 di1 dt, right? So I will take everything else on that side. So what I will get here is I1 R1 minus of VC plus of VI, right? Okay, this is also minus, right? This is also minus, this is also minus. So what do I get? So how did I, okay, this is first, okay. So I will divide by L1, and this is I1 dot only. So this is minus I1 R1 by L1 minus VC by L1 plus VI by L1. Okay, so this is my like my first equation basically for the state space, right? This, let me name this as 1. This will be my third equation basically. And now let's do the KVL in the second loop. So this is the first loop, this is the second loop. So this is the first loop. Second loop. So the second loop, right? For second loop, what do we have for second loop basically, right? So I will apply like this equation. So this is minus VC plus VL1 into I2 R2. So I will not write V of I2 R2, right? So this is minus VC plus VL2 plus I2 R2 equals to 0. Plus I2 R2 equals 0. Okay. So yeah, what will be basically VL2? It will be L2 di2 dt. This one was I1, right? Yeah, I2 dt equals to, this is VC is going that side, so this is minus I2 times R2 plus VC. So I2 dot equals to minus I2 R2 by L2 plus VC by L2, right? So this is my I2 dot equals, so this is my second equation. This is my second equation. Okay, so yeah, now let me like write the equations in the matrix format. So again, like this will be a bit big, so I have to make everything smaller now. So let me first make the format itself, right? So let me make this bigger, right? Let me make this a very big I1 dot, I2 dot, and this is VC dot, right? And we have the E matrix. Basically I will write the U matrix later. So first let me write the E matrix, then I will minimize this. Okay, this is I1, this is I2, and this is VC itself. So all of them are functions of time. That is understood, right? So I'm telling repeated because a few students may get confused, right? Why are you not writing bracket of t? Is it constant? No, it is not constant. They are function of time. To save time, basically I'm not writing bracket of t. Okay, and also I'm a bit lazy. So like what will be my system matrix basically? This one, right? So what is I1 relation? This is minus R1 L1 minus 1 by L1 minus R1 L1 minus 1 by L1, and this, right, is one like that is input that I will write later. Okay, and for I2, right, so this is 0. This is okay, sorry, I made one mistake. This is not related with I2, but this is related with VC. So this will come here, right? This will come here, and this will be 0 because this is not related with I2. So now for I2 dot, what I will do? So for I2 dot, right, I will get minus R2 by L2 and 1 by L2. So this is related with I2, not I1. So this will be minus R2 by L2, and this will be 1 by L2, 1 by L2. Okay, and this is 0. Okay, this is 0. This is not related with I1 basically. So now, right, for VC dot, we have to go to the first page. This was the first stage. So this is related with I1 and I2, not with C. So we have I1 and I2. So this is so not I1. This is 1 by C, and this is minus 1 by C, I think. So like it was minus I2 by C, right? So this is minus 1 by c. So this is 0. It is not related with vc. Okay, so yeah, this is basically the A matrix. Now let us solve for the U matrix, right? So U, right, only this state variable is related with the input, okay, with coefficient 1 by L1, other ones are 0. So this is the first state variable, right? So this will become 1 by L1 0 0, and this is vi of t simply. So now what I'll do, as this is looking ugly, I will reduce the size. So yeah, we have to make it look beautiful also, right? So you guys don't like things ugly. So yeah, this is plus, and let me change the color also, so that will also make it a bit better. Now this is not looking good. Yeah, this is looking good. Now this is the, what is this? This is the state equation. So this is our state equation. Okay, yeah. So now, right, let me compare this with this equation, right? Let me copy and paste this one. I also find the xyz. So xyz is easy, right? X is 1 by L1 only, and like yz are 0 only. Okay, so here comparing, okay, let me color this differently actually. Then this one I will color like this one. Okay, so from comparing, right, comparing what I get, minus r1 by L1 equals to minus 4. So r1 by L1 equals to 4 itself, one relation I get, and this is 1 by L1 equals to 1 minus 1 by L1 equals to minus 1 by 2. So basically L1 equals to minus 1 by L1 equals to minus 1 by 2. So L1 equals to 2, right? L1 equals to 2 Henry. Okay, so I get L1 as 2 Henry. So what is R1 equals to? So R1, right, R1 will be equals to 8 ohms. Okay, now another relation from the second row, what do I get? So minus R2 by L2 equals to minus 3. So R2 by L2 equals to 3, right? And 1 by L2 equals to 1. 1 by L2 equals to 1. Okay, so what is L2 equals to? 1 Henry only, right? So R2 equals to 3 ohms only. 3 ohms only. Okay, R2 equals to 3 ohms only. Okay, so now, right, now like the third row. So basically 1 by c equals to 2 only, right? So 1 by c equals to 2, so c will be 1 by 2. So c will be 1 by 2 farad. Okay, so I got the values of R, L and C also, right? So x equals to 1 by L1, basically it was 1 by L1, right? Yeah, 1 by L1 equals to x. So what is L1? L1 equals to 2 only, right? So this will be 1 by 2. Now what is y? Y will be 0 only, and z will be 0 only, as from directly comparing, right? So yeah, 0 0. So this is the basically the solution of question for the first part, right? For the first part. So yeah, let me write it for the first part. Okay, this is on 24, right? So the first part, this is solution for this part. Now let's draw the state diagram, which will be a bit difficult. So say state diagram. For state diagramming, right, what I will do, I will write the equations. State diagram, I will write the equations. So what is like from matrix format, I will go into this format, right? What I can do is simply, okay, in terms of state variable, I can write. So I can copy the the equations 1, 2 and 3. So what was 1? 1 was this one, right? Okay, this is written in R1, R2, so I have to write it in like a simple number format, right? So I will write the matrix itself. So here, right, okay, let me copy the matrix and then write the equations. That will be easier. So my I1 dot of t equals to minus 4 of I1 of t minus of Vc of t divided by 2. That this is 1 by 2 also. Okay, also okay, this is x is 1 by L1, so 1 by L1 is 2 only, so this is half, right? Half 0 0, so this was half, right? Yeah, this was x was half only, so this is 1 by 2 Vi of t. Okay, and what is this? This is I2 of t. Okay, which is equals to minus 3 I2 of t plus Vc of t plus Vi, right? Vi is 0 only, so this is 0 only. Okay, let me write the final equation. This is 2 I1 of t, okay, minus 2 I2 of t, and this is 0 only. Okay, this is 0 only. So yeah, these are the equations basically. So now I will draw the state diagram with the help of these equations. So I hope you remember a bit of steps, right, that we remember, right, during the first few lectures what we did. Okay, so I have three state variables. So what I will do, I will draw 6 points, okay, 6 nodes in the state diagram. Okay, and we won't use that simple state diagram. I will space out everything, right? So I have one input is always on the left side, so I have one input at the left hand side and one output at the right hand side, right? Now I will draw points in between, right? So what I will do, this is 1 2 3 4 5 and 6, right? 5 and 6. Now one thing I notice is I2, like y is directly related with something, like my VO. Okay, like VO, right? What was my VO? So I forgot to write the output equation also. So VO, right, here VO was I2 times R2, right? So here, right, I will write the output equation also. VO was I2 of t times R2, right? So it is directly not related to the input, so I2 is there, right? So what I will do, this is VO only. Okay, this is right hand side most point is VO only, and this left hand side most point is Vi only, right? But okay, let me not write bracket of t because this is in Laplace domain, that's why. But like what I can see is this is directly related with I2, right? So I can write I2 here. Okay, I can write I2 here, and I can make a connection of gain, simple R2, right? Now what is R2? So R2, right, R2 was 3 in our case, so I will replace this R2 with 3, simple 3. Simple 3, right? So this is 3. Okay, so now I2 I have here, right? So the previous value of this one will be directly I2 dash. Okay, always keep in mind the previous value will be I2 dash. So this will be 1 by s and this will be I2 dot, right? So what is my I2 dot equals to? So my I2 dot is basically related with this equation, right? This equation. So it is equals to minus 3 I2 plus Vc. It is not simply equals to Vc. Okay, as like in the first few lectures what we should do, right? We should do this simply I2 dot equals to Vc, then we should do Vc dot equals to I1. No, we won't do like this isn't like that form. State space can be in many formats, like this is one of the formats. So for in this case I can simply write Vc equals to I2 dot, right? So I have to write it like this. So Vc times 1 equals to I2 dot. So what I will do, I will write here 1 and this will be my Vc, right? And also I2 dot equals to I2 times minus 3, right? Like basically minus 3 I2. So yeah, okay, I will have to put a gain block of minus 3. Okay, so this is minus 3. Okay, so yeah, Now right now, like what is like VC, just before VC what I will do, again do the 1 by s, right? VC dot, so that will always be constant, that is no worries. So this is equals to VC dot, so this is equals to 1 by s only. Now right, what is VC dot equals to, what is VC dot equals to, VC dot, right, VC dot equals to 2i1 minus 2i2. So like we have to bring back 2i1 also. This is minus 2i1, so I have to bring it like this. I can bring it from the top, 2i1. Okay, so I have only left i1, right? So I will put like one thing to notice here is i1 dot is directly related with v1, right? So I will write i1 dot here, as two places are only left, i1 dot here and i1 here, right? So this is related with i1 also, so 2i1 minus 2i2, so 2i1, right? 2i1, what is VC equal VC dot equals 2i1, so I will write it like this. Okay, I can write it like this, right? 2i1. Okay, and like what I can do is again the loop, right? Minus 2i2, so I can write it like this, minus 2i2. I can, okay, I have to bring this bit side. Minus 2i2 and minus 3i2. Okay, so this is basically VC dot. So now right, so I will write the equation. VC dot is finished. I will write it for i1 dot. So what is i1 dot equals to? i1 dot is equals to minus 4i1. So I have to take another loop of minus 4. This is 1 by s also. This is 1 by s, right? This is only 1 by s. I have to take a loop of minus 4i1. So I can take it like this one. Okay, and what else I have to take? I have to take half v1. Okay, half v1. Okay, and what else I have to take? I have to take minus 1 by 2, right? Minus 1 by 2 VC, minus 1 by 2 VC. So this, right, this will come like this one. So let me bring it over here a bit. Okay, can I take, I should have taken it from the top. Okay, what I will do is I will take this loop from the top. This is just for representation, nothing else. So what was minus 4i1, right? So this is minus 4. Okay, and this is minus half, right? So this is minus half only. Okay, let me bring this over here. Minus half only. Okay, minus half only. So basically, right, this is my state space diagram for this particular like equation, right? So yeah, I think that's it. So again, like, am I doing something? Okay, this is VC by 2. Okay, fine, and this is i1. Okay, yeah, I think basically that's it for this like state diagram. That's it for this question basically. Okay, so let us go to the like the next question, right? So what is our next question? So next question is this one. So we have been asked to find the like take the screenshot of the question, right? Take the screenshot of the question, then you solve it for yourself. Okay, solve it for yourself. This is a gate EC question. Okay, or you just pause the video and solve it for yourself. Now I will read the question. So the state space representation of a separately excited DC servo motor is given as this one, right? Is given like this. Okay, we have to find the transfer function W of S upon U of S of the motor. Okay, of the motor. So you might say we have to find the transfer function, right? So what finding the transfer function, what do? So you simply do C into Si minus A inverse into B, right? That is like that I told you to mug up, right? Transfer function mug up C into Si minus A inverse into B. But the problem here is you don't have any C here. Okay, also it is not asking us to find the transfer function of the input output, okay, not the input output. It is asking us to find transfer function w upon s. Just check once what is w and what is u. U is input, that is fine, but w is not output, right? W is a state variable, okay, w is a state variable, okay. So what you have to do, we have to write the state equation, and from there do the Laplace inverse and then find the transfer function, okay. So yeah, that was the important point to note here, okay. So solution, right? What is the solution? So like write the state equations. Write the state equations. So what are my state equations? They are dw upon dt equals to this minus w plus ia, and it is not related with u, and dia upon dt equals to minus w, this is minus 10 also, minus 10 ia plus 10 u, okay, plus 10 u. Now if I take the Laplace inverse, right? Now if I take the Laplace transform of this, so what will I get? Laplace transform of both the equations. So what I have to do is simply, right, take the Laplace transform and eliminate ia, okay, and then I will find the relation between u and w. That is the main thing that you need to do in this. Like whenever you're solving gate questions, right, you think about concept, but just think, how will I solve the question? Main thing is, how will I solve the question correctly, okay. So that's how you will get the marks, right? That is more important. So taking the Laplace transform of both the equations, so the first equation I get w like s and minus, as I need to find transfer function, right, initial condition 0, and anyways nothing is given, so I consider 0, minus w of s plus I of s, this I of s equals to minus w of s minus ten I of s into 10 u of s, right, 10 u of s. So what I have to do is simply eliminate I of s. So what I will do, I of s equals to okay, 10 is like what I can do here is, okay, this is I of s, okay, I can replace I of s, right. So I of s equals to this, from the first equation, I of s equals to s plus 1 into w of s. So I can replace this I of s in the second equation. So s plus 1 into w of s times s minus w of s minus 10 s plus 1 w of s, okay, plus 10 u of s, okay. So yeah, this is basically now I will just rearrange the w of s terms. This is simply s square plus s, and there is also one 10s over here, so 10s will come over here, this will become 11s, okay. I hope like calculations you can do by yourself, right? That is what you have to do, okay. This I won't explain it to you everything. So this is 10, and also one will come due to this one, right, this one. So this will become simply 11, and on the right hand side we have 10 u of s, right, 10 u of s. So now I will find the ratio transfer function w of s upon u of s, which is simply 10 upon s square plus 11s plus 11, right. So this is my answer for this question basically. So this is A only, the option is A only, okay. The option is A only, right. So now, right, is there any other method to solve this question? So what you can do is go in the opposite direction, right. go in the opposite direction, that you find the what do you say, state resolvent matrix, and from there you will find the transfer function of both of them with respect to the input, right, with respect to the input. So method 1 was simple, like right state equation. This one was the method 1. What is method 2? Method 2 is simply, right, state resolvent matrix. Okay, if spelling is wrong, then please excuse me. State resolvent matrix. So this is x dot. So what is our state equation? It is ax plus bu, right? So what I can write here is that, like, x in terms of b, right? X in terms of b, how I can write? So x will be simply si minus a inverse bu, right? This is my simple equation, right? Now what is si minus a? This is simply equals to my phi of s. This is simply equals to my phi of s. Okay, so right, this is my si minus a inverse. So what is this? So what is my si minus a inverse? Simply, right, like a is this, like s plus 1 minus 1 plus 1 s plus 10. So s plus 1 minus 1 plus 1 s plus 10. Okay, and the inverse of this. So what is the inverse of this? Okay, the inverse of this, right, is simply 1 by s plus 1 into 1 by s plus 10, and this is plus 1, and like I will swap them. So this is s plus 10, s plus 1. So yeah, this is basically my resolvent matrix at phi of s. So what I will do, I just simply multiply phi of s with b, right? So let me change the color of the pen. If I simply just multiply phi of s times b, so what do I get? So phi of s times b, right, is like, what is b? B is 1 0, I think. Yeah, now v is 0 10, right? V is 0 10. So if I multiply 0 10, so what do I get? So like this multiplied, okay, let me take this multiplied. Okay, let me copy this anyways, because you will get confused again. Like this one multiplied with this one, and 1 multiplied with 10, so we are left with 10 only. So this, right, this becomes s square plus 11s plus 11, and this is 10 only, and this one is 0, and this one is 10s plus 1, 10s plus 1. Okay, so yeah, now, right, so what is this like phi of s times b? This is phi of s times b, right? Now I can write it directly in the equation. So this one was my x of s matrix, right? So what was my x of s matrix? It was simply, first one was w of s, second one was what was it? Ia, right? Armature current, speed and armature current, basically. Yeah, Ia of s. What is my, like, this equation? So this equation, right, becomes, this equation becomes 10 by s square 11s plus 11, and this is 10 by s plus 1 s square plus 11s plus 11, right? Okay, this is my basically both of the equations, right? Both of the equations, and this is my u of s, right? U of s. Okay, so yeah, this was my first transform function, and this is my second transform function, basically. Okay, that's how you can directly solve this, right? So this is method 2 for solving this using the state resolvent matrix. Okay, so yeah, let me write here also that W of S upon will be equals to S square plus 11S plus 11 and IA of S upon U of S equals to plus 11, right? So these are the two equations basically. Now, right, we'll go for the another question. So this is again a common data question. So the first question is, we have to, like, the state flow graph is given, right? We have to find the state variable representation. So this is just a revision of the first few lectures. So I hope you are revising also. So yeah, all these are revision. This is a gate question also. Okay, EC 2010. So what you do, you take the screenshot or just pause the video, right? You pause the video, then you basically start. I mean, you solve the question. Okay, then you start after solving the question, right? So what the question? Find the state variable representation. Okay, also find the transfer function. Transfer function is easy. What you can do, use the Mason's gain formula and directly find, right? But if I don't how to use the state space representation, right? How to write the state space representation? So remember, right, we had few steps, right? What was the step 1? Try to remember what was the step 1. Okay, step 1 was this is the part A basically. Step 1 was we have to remove the initial conditions, as no initial condition is anyways given, so that step is anyways like eliminated. So remove initial conditions, right? Remove initial conditions. So yeah, let me say, draw the state diagram, because else it will be difficult. So I have this 1, 2 and 3. This is 2 only. This is 1 vase. This is 1 vase. This is 1. And this 1 vase is coming from here. We have gain of 1 here. Okay, this is 1 and this is 0.5. So yeah, this was the, okay, we have 2 loops here also. So this is -1. Okay, and this is -1 also. This is -1, this is -1 also. So they haven't named the state variables, right? So I will name it according to myself. Okay, now one thing to note is that if for some reason I see, yeah, they are same, this matrices are same, but they are somewhat changed, right? Like they are somewhat transposed. If they are transposed, basically whatever they have chosen as x1, I have chosen as x2. Okay, that is just the opposite thing. Else the matrix will be same, and this columns will be rows and rows will be columns. If that is the case, right, x1 will be x2 and x2 will be x1. So that is the important thing. Basically this will be solved, right? So yeah, so what I will do, I will choose x1 and x2. So initial conditions aren't even given, but I will choose x1 and x2. So x1, right, is, I will choose like this one. Okay, I choose x1. Okay, I can choose x1 this one, because this is directly going to the, there are multiple forward paths over here, right? this is one forward path and this is also another forward path. So I can't choose x1 this one. What I'll do is I'll choose x1 like this one, okay, because it has multiple forward paths over here, right? This is a forward path and this is also a forward path. It has two, so I can choose x1 here, and I should choose x1 just after the one way stem, right? Just after the one way stem. So this is x1, and just before the one way, this will be my simply x1 dot, or you can say x2, okay, you can say x2. Now this will be my x1 dot, and this will be my like x2 dot also, okay. I don't need to choose another x3 variable, but I have to choose x3 variable because this may have multiple forward paths, right? That's why just temporarily I will choose x3 variable, as I taught you in that previous first few lectures, right? So yeah, this is x3. Now I will convert this into time domain basically. So basically like I've already written it here, okay, written it here. So I have converted into time domain. So I will convert this into time domain. So like remove the one way terms basically. So yeah, let me take the copy of this. So this one base term will be removed. Okay, this all this one base terms will be removed, so we will be left with only this one. So x3, right? x3 I can write or not write, doesn't matter. So one thing I can notice here is like, are there like any multiple forward paths? So for now, yeah, there it was, okay, here it was, but that's why I chose x1 like this one, okay, but here it isn't, right? So I can simply write the state equation instead of that like transfer formula, right? So what I will do, simply write, I will write the equation like this one. So one more thing what you can notice over here, okay, look, they have changed this one. So one thing what is constant is this one, right? The 0 2 is constant, the 0 2 is constant. So here, right, here will always be a state variable, either x2 or x1. So they have given like x2 as this one, right, 0 2, okay. So from here also I can understand this is x2 dot, right, because this x1 x2 comes in the bottom. So here our row and column will be interchanged, right? So from this you can take the hint what to choose x1 and what to choose x2, okay. This is a big hint, right? All of them are constant, like same in the 4 options. So if I choose my x, because this is x1 dot and x2 dot, so this x2 dot equals to 2u, right, plus something, this one, right? So this one I will disregard, this one is important. So 2u is coming over here, so this must be x2 dot, okay. So yeah, that's how you can also choose the x1 dot or x2 dot, okay. From options, always check the options, there will be some hints at least, okay. So yeah, just you have to be smart enough. So yeah, I can remove the x3 for now, okay, because I only need x2. So and like this has only one forward path, okay, and no forward path is coming from here, from x1. Yeah, from x1 it is coming, okay, but there is no other forward path from x1, okay. So this x2 dot equals to simply 2u, this is also 2u of t and y of t basically, u of t and y of t, okay. Two u of t minus x1 of t, right? 2 of t minus x1 of t, this plus, okay. And like what is x1 dot of t? So x1 dot of t, right, we have only one thing incoming, that is this minus x1, right? So x1 dot of t is minus x1 of t. And what is this y of t? So y of t, right, y of t is only this one, right, only this one. We have only this one. Do you have anything else in this x? Okay, sorry, this x2 was also there, so sorry, like I missed one part. So there was one x2 also here, okay. That's what happens, right? That is why we should take this separately. Okay, the thing is, the problem here is always, right, always take these things separately, right? So that's the first thing that I told you, right, during the state space representation, that this is one only, this is two, like in the previous question, right, in the electrical first question of this lecture. So what did I do? I took these two separate, right? Why? Just so that no confusion happens, right? No confusion happens. So x2 will not be equals to x1 dot always. Okay, not always. So that's why I will write them separately. Okay, even though in the state space diagram they haven't shown it actually here, so it's their mistake. They should have shown it, right? They should have shown it. So yeah, that is one thing that we need to keep in mind, right? That is one more thing that we need to keep in mind, that always, right, always we should have like this x1 dot before this, right? Before this, it may be x2, it may not be x2. Just to be on the safer side, always put a gain of 1 with x2 and then add it, right? If nothing else is incoming, then x1 dot will be equals to x2 only. If anything else is incoming, then yeah, it will be that also. So you just have to keep in mind. So x2, right, will be equals to x1 dot. So yeah, these things are very important actually. So these things you have to keep in mind. So always while you solve the state space diagram, you write the state variables and just one by s term. After one by s we have that let's say we have x2, and before one by s we have that x2 dot. But after x2, right, like just at x2 you shouldn't write directly x1 dot. Okay, you put a gain of 1 and then you write x1 dot. So that will be the safest option to, like, so that you don't make any mistake in the question. Okay, so this is what the gate exam is all about. It's about a trap, right? So yeah, I also fall into the trap sometimes, so everyone falls in it, but you have to minimize it, right? You have to minimize it. So yeah, this is x2 and x1 dot. So this x1 dot, right, this x1 dot equals to minus x1 plus x2 plus x2. So this is how you won't make any mistake, right? So now what is y equals to? So y, right, y equals to this x2 is coming over here. Okay, this x2 is coming over here and this x1 is also coming over here. Okay, two of them are coming over here, right? So like here at this point, what is the value? At this point the value is x1 plus x2, right? x1 plus x2. If you even do the the Mason's formula, from there also you can see, like, we don't have any loops anyways. Okay, we don't have any loops anyways, so like it will be simply just forward path gain and forward path gain, addition of the both forward path gains, right? So you do that, homework is for you. So y of t equals to 0.5 times x1 of t plus x2 of t, right? So yeah, this is what y of t equals to. But one thing to keep in mind is this right, x2, right? What is x2 equals to? So okay, wait 1 second. So x2 equals to simply x1 plus x1 dot plus x1, right? Sorry, am I doing some mistake? Okay, this is x1 dot of t times 0.5 this. Okay, so what is x1? Okay, what is x1 dot of t minus x1 plus x2? Okay, yeah, I can write it in terms of this only. Okay, I can write this in terms of this only. So this is like, okay, am I doing some mistake? This is okay, sorry, I can't do, because there are two incoming nodes here. Okay, sorry, I am also making a mistake, right? So I can simply write it like this. Why? Because, right, there are two incoming nodes here. So what I can do is write directly x1 dot times 1 and x1 times 1. That is a mistake. I can write simply x2 into 1 like this. No. Why? Because this x1 is also incoming here, right? X1 is also incoming here. So that is my silly mistake. So this x1 dot times 0.1. So this will be x1 dot of t plus, this is only x1 dot, right? And this is x1. So at this point, what is the value? x1 dot of t and x1, right? So x1 of t into 0.5. Now what is the value of x1 dot of t? So this is minus x1 plus x. That's why it was mistaken. That's why this was mistaken. So x1 dot of t I can replace with this one, right? So minus x1 plus x2. So this y of t minus x1 of t plus x2 of t plus x1 of t. Okay, so now right now we get 0.5 into x2 of t equals to y of t, right? So yeah, this is basically like what my y of t is. Okay, so right, so like yeah, let's write the state space equation basically. X1 dot of t and x2 dot of t. What is my a equals to? So my a, right, is minus 1 1. So okay, this is minus 1 1 and this is minus 1 0, right? Minus 1 0. This is my x1 of t and x2 of t. This is basically 0 0 2, right? 0 2 basically, yeah. Zero 2. Okay, so yeah, this is 0 2. Now basically let me write the output equation. So the output equation, right? Output equation is basically 0 0.5 and this is x1 of t and x2 of t. Okay, this is my output equation. Okay, so like let me compare with the quotient, right? Compare with the quotient. If I compare with the quotient, this first one, right? First one is matching. This first one is basically matching. So yeah, this first one will be correct only. The second one, like I have minus 1 1 and minus 1, but this one, okay, what is wrong? Okay, here I have minus 1. Okay, now this is wrong. So at first I had 1, right? Okay, sorry, at first I have minus 1, then I had 1. Okay, at first I had minus 1, then basically 1. So like my b will be correct only. So I had first minus 1 and then 1 minus 1 0. Okay, and this is incorrect also. This is also incorrect. Okay, so this is where you will make mistake, right? Why they have given it like this? Because what you will do, you will do directly x2 times this x2 times this one and x1 times 1 and add these two and you will get your output as 0.5 times x1 plus x2. Yeah, that was what I was also making mistake. Okay, so yeah, you have to keep in mind that there are multiple nodes incoming here. Okay, and x1 is also hidden here, x2 is also hidden here, it is incoming here. Okay, so that's why you can't do like that. So these options are eliminated anyways. You're only left with these two options and the first element was minus 1. Okay, everything is same. First element was minus 1 and then 1. So yeah, this will be correct. Here signs are same, signs will be different in like two of the cases, right? So our option will be b, right? So yeah, this is basically my transfer function. So now, right, so this is y of t, this is x1 of t, this is x2 of t. So like okay, option b we get. Now is there any other method? So other method is simply what you do is simply find the transfer function of each of them, right? Simplify the transfer function of each of them and from there you solve, right? Okay, anyways you have to find the transfer function. You first find the transfer function and find the transfer function of each of this matrix and you solve from there, right? Okay, so yeah, I will do that. I will do that basically. Just wait 1 second. So this is basically method 2 basically. Find using transfer function. Okay, so what is the transfer function basically? The transfer function, right? Transfer function, let me solve for the graph. So what are the number of forward paths here? I can see 1, I can see 2, right? From input to output Okay, so we have two for paths. So what is the value? Value, right? Value is simply this first forward path is this one. Okay, all of the loops, right? Two of the loops are like outgoing. Okay, I mean like they're touching, so none of the loops will be present. So first forward path is 2 times 1 by s times 1 by s times 1 by 2, so it becomes 1 by s square. So 1 by s square times 1 minus 0, basically this plus, and what is this? This is 2 times 1 by s times 1 by 1 by 2, so this is 1 by s only. And again, right, am I covering all the loops? Yeah, this node is going out, so this should be fast by you. Okay, now we should have grip in this. So this node is going out, so I'm only left with I'm not left with any of the the loops, right? Again, my associated loop gain will be 1 only. Okay, so this is 1 by s times 1 minus 0. I hope you should do it by yourself. You don't need to take my help, right? This should be in your grips. So what is my determinant basically? So this is 1 minus the loop gains. So this is one of the loops and this is another loop. So is there any non-touching loop? We have only two loops and they are touching each other. So yeah, so this the loop gain is 1 by s times minus 1, so minus 1 by s square, and this is minus 1 by s. Okay, so this is right. So if I multiply s square both numerator and denominator, what do I get? I get here this is 1 and this is s plus 1, and this is s square, this is plus s plus 1. This is yfs upon ufs. Okay, this is yfs upon ufs. So now, right, now you have to check from options. So one thing what you check is, so this one, right? So this one you check, okay, and this one you check, this one you check, this one you check, and you will see that this is the correct option. Okay, I will not check, okay, because that will make the lecture lengthy. So si minus a inverse you do, okay, si minus a inverse, and you do b times c. Okay, this is a true cross 2 matrix, so this will be this will take less time, right? This will take less time. So check the options, homework for you, right? Check the options, homework for you. And I have solved the transformation anyways. Check the options. Homework for you. Okay, many days I haven't given you homework. Okay, now I will give you a few questions also, that those will be homework also. Okay, so this is option B. This is, what is this option? This is like s plus 1 into s square plus s plus 1. Yeah, this was this option, right? C option. Okay, so this is option C. So yeah, this is this option. So I will give you a few questions for homework, because this lecture has already gone over 1 hour. So all these are mostly gate questions. Okay, these are mostly gate questions, so you will have to solve these questions, and in the next lecture I will solve this question, right? So this is one question, take the screenshot. Okay, EC 2011. This is another question. This is also gate question, but pretty old question. So in old question, right, some data are missing or something. Okay, just assume anything if some data are missing, right? So in this question some data may be missing. Okay, so yeah, just a hint. Then this question, have you taken the screenshot? The state matrix equation is given, and the control signal is also given. Okay, what is control signal, what is this u, then what is this v, what are this? Then the question is asking us to find is the eigenvalues of the closed loop system. What will be the eigenvalues of the closed loop system? Okay, so this is another question. So we have okay, this is also another question. The state variable system is given. Okay, the state variable system is given, x dot tv, this given x of 0 equals to this, and input is unit step. Okay, input it is given in unit step. What this question is asking us to find the state transition matrix. This is easy only, right? You can even apply the properties also. From there you can directly solve it. Okay, without even going into the going to the equations and all those things. Directly apply the property and you solve it in gate, right? But now you're practicing, right? You practice, you solve it using the normal method that you do, right? So yeah, also you need to find the state transition equation, okay, or you can say transition response also. So state transition equation, you can say, yeah. Okay, is there anything else? I think there is one more question. Yeah, this one is the last question. So this is also, I think this is also a gate question. Yeah, I forgot to put the like year. This is also a gate question, right? This, I think, is a gate question. This is a gate question, but I forgot to put the year here, right? So yeah, like you solve the question. State diagram is given again, right? You have to find the state equation, okay, and the state transition matrix. State transition matrix again you can solve using properties, and state equation is difficult this time. Okay, try to solve it. Here, right, they have always given you this hint that this, right, this is constant, okay. So like take this hint, take the help of this hint. From here you will understand what to choose x1 and what to choose x2, x1, x2, okay. So yeah, that was it for this lecture. I will see you in the next lecture solving this question, right? Thank you for watching.